So in this question, you're given that f of x is equal to 1/3 of f of x plus 1 plus 5 by f of x plus 2. And f of x is always positive. So you're asked to find limit x tends to infinity f of x. So you're given a functional equation f of x is equal to 1/3 of this plus this. So from this information, can you find the value of f of x? It's not very easy. So this is a successive definition, recursive definition. This you have f of x and f of x plus 1, you can find f of x plus 2. If you have f of x plus 1 and x plus 2, you can find f of x plus 3. So this is a very typical question. So in this type of questions, what you need to do is, if limit x tends to infinity f of x exists, if this exists, that means as x goes to infinity, f of x plus 1, f of x plus 2, all of them tend to the same value. They have to tend to some value which are almost equal. Because as x tends to infinity, if some limit exists, that means in that region, as x tends to infinity, fx has to be same as x plus 1, because x plus 1 also goes to infinity. As x tends to infinity, x plus 1 also goes to infinity, x plus 2 also goes to infinity, right? So if this is equal to L, so if I apply limit x tends to infinity on both sides, so limit x tends to infinity f of x has to be equal to 1/3 of limit x tends to infinity f of x plus 1 plus 5 by f of x plus 2. So as x tends to infinity, if f of x goes to L, limit x tends to infinity, f of x plus 1 also goes to L, right? Because as x tends to infinity, x plus 1 also tends to infinity, and plus 5 by f of x plus 2 also goes to L. This is the equation which L has to satisfy. This implies 3L is equal to L square plus 5 by L. This implies 3L square is equal to L square plus 5. 2L square is equal to 5. L is equal to plus or minus root of 5 by 2. But it's given that f of x is always positive, so this negative has to be discarded. So value of this limit is square root of 5 by 2.